Ancient builders achieved feats that leave modern experts speechless. This video explores 25 ancient engineering puzzles that fundamentally challenge our modern understanding. By the end, you will see the past not as a simple timeline, but as a landscape of profound and mysterious human ingenuity. How did a civilization without wheels move 800-ton stones? And what is the purpose of a 2,000-year-old bronze computer found in a shipwreck? These creations suggest we might be missing entire chapters in the story of human innovation. What does it say about us if our ancestors' greatest works still hold secrets we cannot fully explain? These puzzles are not simply old things we do not fully understand. An ancient engineering puzzle is something far more specific and far more provocative. It represents a clear disconnect, a jarring mismatch between what a civilization is historically believed to have been capable of and the physical object that stands before us. It is an artifact that, by all conventional logic, should not exist in its time and place. Often, this gap manifests in three profound ways. The first is impossible scale, moving or shaping materials of such staggering weight and size that our textbooks struggle to explain the how. The second is impossible precision, achieving alignments, angles, and surface finishes with a degree of accuracy that rivals, or sometimes even exceeds, what we can accomplish with modern machinery. The third is the mystery of material and method, using substances or techniques that archaeology suggests were unknown, or employing a process so efficient it seems to have been forgotten for centuries. Each of these anomalies is a quiet rebellion against the smooth, upward curve of progress we often imagine. They are not mere curiosities, they are evidence. They suggest that our story of technological advancement might have missing pages, or even entire chapters written in a language we have yet to decipher. When we look at these structures and devices, we are not just looking at stones and metal, we are looking at questions carved in granite and cast in bronze. We are engaging in the ultimate detective story, where the clues are millennia old and the mystery is the full scope of human ingenuity itself. This foundational idea transforms our list from a simple catalogue of wonders into a focused investigation. With this lens, let us examine the first and perhaps most iconic example of this puzzling disconnect. The very existence of these ancient puzzles ignites a fierce and fundamental debate about human history itself. This is not a quiet academic disagreement. It is a full-scale battle of paradigms, a clash between two very different ways of seeing our past. On one side stands the prevailing view of mainstream archaeology and history. This perspective champions human resilience and ingenuity, arguing that with enough time, enough labor, and clever application of simple tools like levers, ramps, and ropes, our ancestors could achieve the seemingly impossible. It is a story of collective effort, of generations working toward a single goal, of skills and knowledge passed down and perfected over centuries. This view finds wonder in the sheer organizational power of ancient societies, their ability to mobilize thousands and coordinate complex projects without modern technology. It suggests that what looks impossible to us today was merely difficult for them, a challenge met with patience and immense human spirit. On the opposing side are alternative theories that look at the same evidence and see a different story entirely. Proponents of these views point to the precision, the scale, and the logistical nightmares that simple tools and manpower struggle to explain convincingly. They ask if we might be missing a chapter, or perhaps several, in the textbook of human development. Could there have been a lost civilization with knowledge that was later forgotten? Could ancient cultures have possessed a sophisticated understanding of nature's forces, from acoustics to astronomy to geology, that we are only now beginning to rediscover? At the furthest edges of speculation, some even look to the stars, wondering if guidance from beyond our world played a role. This side of the debate argues that mainstream science is too quick to dismiss anomalies, that it sometimes forces the evidence to fit a pre-existing narrative of linear, gradual progress. This tension is about far more than just how a block of stone was moved. It is about how we define human potential. Are we guilty of underestimating the brilliance and capability of our own ancestors, imposing our own technological biases on their achievements? Or does the evidence genuinely point to a historical discontinuity, a gap in our understanding so wide that it requires us to reconsider the entire timeline of innovation? There is no easy answer, and each ancient puzzle we examine becomes a piece of evidence argued over on this intellectual battlefield. Understanding this controversy is not about choosing a side before we begin. It is about appreciating the depth of the mystery. It allows us to look at each wonder not just as an artifact, but as a question that challenges the foundations of our historical narrative. With this framework in mind, the stage is set for our investigation. That fundamental question about human potential finds its purest expression in the very first wonder on our list. The Great Pyramid of Giza does not simply sit on the desert plateau. It is locked to the earth itself, oriented with a precision that defies its 4,500 years. Its four faces are aligned almost perfectly to the cardinal directions north, south, east, and west, with an error of just 3/60ths of a single degree. To understand how astonishing that is, consider what they did not have. The magnetic compass would not be invented for thousands of years. Modern satellite guidance and laser theodolites were the stuff of pure fantasy. Yet they established true north, the axis of the planet's rotation, with an accuracy that would challenge a skilled surveyor using basic equipment today. How theories abound, each a testament to a different kind of ingenuity. Some scholars point to the stars, suggesting the builders used the pole star of that era, a star called Theban, tracking its arc across the night sky over an entire year to find that fixed celestial pivot. Others propose a method using the sun, perhaps by bisecting the angle of a shadow cast by a vertical rod at the equinox, when day and night are equal. This would create a perfect east-west line from which a true north-south line could be derived. The puzzle deepens when you move from the pyramid's orientation to its foundation. The base of this colossal structure, covering 13 acres, is leveled to within less than 1 inch. Across an area larger than 10 football fields, the stone platform varies in height by no more than the width of your thumb. This is not merely stacking stones. This is geodetic engineering, the precise marrying of a monumental object to the curvature and orientation of the planet itself. It suggests a society that did not just build tombs, but one that thought in scales of cosmic order and terrestrial measurement. The precision was not an accident or a happy byproduct of simple construction. It was the foundational requirement, the first and most critical step in a project that would last for generations. This level of accuracy forces us to ask not just how they did it, but why it mattered so profoundly. Was it purely symbolic, aligning the pharaoh's eternal resting place with the eternal circuits of the heavens? Or was it a demonstration of a far more practical and sophisticated understanding of mathematics, astronomy, and the very shape of their world? The Great Pyramid's silent, perfect alignment is our first concrete piece of evidence in this investigation. A 3/60ths of a degree deviation that opens a 1,000-year-wide question about the true capabilities of an ancient civilization. That same obsession with monumental scale and perfect alignment appears again, but this time in the most isolated place on Earth, Easter Island, a speck of volcanic rock in the vast emptiness of the Pacific Ocean, presents a puzzle of a different nature. Here, the challenge was not aligning to the stars but moving mountains across the Earth. The famous Moai, those brooding stone giants, are not simply heads. They are full torsos carved from solid volcanic tuff, with the largest among them standing over 30 feet tall and weighing more than 80 tons. They were quarried from the slopes of the Raraku volcano, and then they embarked on a journey. Some of these multi-ton statues were moved over 11 miles of rugged, hilly terrain to stone platforms called ahu along the coast. This fact alone, on an island with no draft animals, no wheels, and a population that historians estimate was never more than a few thousand, is staggering. It is a logistical equation that seems almost impossible to balance. How do you feed the workers, organize the teams, and execute such a risky operation with such limited resources? Modern experiments have offered one compelling theory, that the Moai were not dragged horizontally but walked. Using a system of ropes, teams could have rocked the statue from side to side, inching it forward in an upright position. It is a method that works in controlled tests, but imagining it on the rocky slopes of Easter Island, with an 80-ton monolith swaying precariously, highlights the immense risk. One slip, one rope breaking under strain, and the work of months or years would shatter on the ground. This leads us to the deeper, more haunting layer of the puzzle. The engineering how is bewildering, but the cultural why is profound. What drove this isolated community to dedicate generations of labor, to consume their limited timber for ropes and sledges, to pour their entire societal energy into creating and transporting these stone sentinels? The prevailing understanding is that the Moai represented deified ancestors, their backs to the sea, watching over the living villages. They were a connection to the past, a claim to land and lineage, and perhaps a manifestation of spiritual power. In this light, the effort was not a logistical burden, but a sacred imperative. The true cost, however, may have been ecological. Evidence suggests that the very process of moving the statues, which required vast amounts of wood for leverage and rollers, contributed to the deforestation of the island. This environmental change, coupled with other factors, likely led to severe hardship for the community. So the Moai stand not just as marvels of transport, but as silent monuments to a society's deepest beliefs and, potentially, to the consequences of pursuing them at any cost. They are a powerful reminder that ancient engineering was never just about mechanics. It was always inextricably about meaning. From the isolated shores of Easter Island, we travel to the high Andes of Peru, where the stones themselves seem to defy the very concept of a straight line. At the fortress of Sacsayhuamán, overlooking the ancient Inca capital of Cusco, we encounter a third kind of puzzle, one defined not by alignment or transport, but by a seemingly impossible fit. The walls here are built from gigantic limestone blocks, some weighing over 100 tons, and they are not rectangular. Instead, each stone is a unique, irregular polygon with anywhere from 12 to 32 sides. These massive, oddly shaped pieces are fitted together so meticulously that the joints between them are virtually invisible. The precision is legendary, with the gaps so tight that not even a razor blade can be inserted. This was achieved entirely without mortar. The walls are a dry stone construction, a three-dimensional stone puzzle of staggering complexity and scale. The visual effect is bewildering, as if the stones melted into one another under some immense pressure, then solidified into a single, seamless mass. This was not merely an aesthetic choice, it was brilliant engineering. The irregular, interlocking design is what gives these walls their legendary earthquake resistance. When the ground shakes, the stones in a conventional rectangular wall would simply slide apart and collapse. But at Sacsayhuamán, the complex jigsaw puzzle of angles and facets allows the stones to shift and settle during a tremor, then lock back into place once the shaking stops. They dance with the earthquake rather than fighting it. This understanding of seismic forces is profound, but it leads directly to the central mystery: how did they do it? The Inca are known to have had only simple bronze tools, which are far softer than the granite and limestone they shaped. How could such tools achieve such flawless, complex surfaces on multi-ton blocks? One persistent theory suggests the Inca might have used a plant-based softening agent, a substance that could temporarily make the stone surface malleable for shaping. While intriguing, no conclusive evidence for such a substance has ever been found. Another possibility points to a mastery of abrasion, using sand, water, and relentless patience to grind the stones against one another until they achieved a perfect match. This would be a process of unimaginable labor and time, a testament to a society that viewed such monumental work as a communal and spiritual duty. The precision we see suggests a level of craftsmanship and an intuitive understanding of material properties that rivals modern engineering. It forces us to ask whether we have underestimated the potential of simple tools in the hands of true masters, or if there is a chapter on Inca stoneworking technology that remains lost to us. The walls of Sacsayhuamán stand not just as a fortress, but as a permanent question, their seamless joints silently challenging our assumptions about what is possible with patience, observation, and stone. That same mastery of material, but on a scale almost invisible to the naked eye, defines our next puzzle. In the year 1900, sponge divers off the coast of a small Greek island called Antikythera made a discovery that would take a century to truly understand. Amid the shattered remains of a Roman cargo ship, they recovered a lump of corroded bronze and wood about the size of a large book. It looked like a piece of junk encrusted by 2 millennia under the sea. Decades later, when researchers finally began to carefully clean and X-ray the object, they saw something impossible. Inside that calcified mass was a clockwork universe. The Antikythera Mechanism is an ancient Greek analog computer, a device of staggering intellect crafted over 2,000 years ago. Its purpose was to model the cosmos. By turning a hand crank on the side, an operator could advance a series of intricate bronze gears, which in turn moved delicate pointers across several dials on the front and back. These pointers could predict the positions of the sun and moon, the phases of the lunar cycle, and even the timing of eclipses years in advance. It could track the irregular orbit of the moon with a special pin and slot device that mimicked celestial mechanics, and it even accounted for the cycles of ancient athletic games like the Olympics. This was not a simple calendar. It was a dynamic, mechanical simulation of the heavens, a portable planetarium powered by human hands. The true engineering puzzle, however, lies in its construction. The device contains at least 30 interlocking bronze gears, some with teeth so tiny and precisely cut they would be a challenge to manufacture even with modern machine tools. The teeth are triangular, and they mesh together with a level of miniaturization and accuracy that suggests the work of master craftsmen who had been building such devices for generations. This is the heart of the mystery. According to everything we know from the historical record, technology of this complexity should not exist in the Hellenistic world of the 1st century before the Common Era. Nothing even remotely similar appears again until the astronomical clocks of medieval Europe over 1,000 years later. It is a technological island in time. So where did it come from? The most haunting theory points to a profound cultural loss. Classical texts mention similar devices being built by geniuses like Archimedes. The Great Library of Alexandria was a repository for the sum of ancient knowledge. Its destruction represents one of history's most devastating intellectual tragedies, where countless scrolls and secrets were lost forever. Was the Antikythera Mechanism a lone survivor, a single, precious example of a sophisticated mechanical tradition that flourished and was then utterly erased? Or was it a singular invention, a brilliant flash of insight that was never replicated, its secrets sinking with the ship that carried it? the mechanism forces us to confront a terrifying possibility that the arc of human knowledge is not a steady, upward climb, but a story punctuated by brilliant peaks and devastating valleys of forgetting. It is a ghost in the gears, a whisper from a past that may have been far more mechanically ingenious than we ever dared to suppose. The ghost of a forgotten mechanical tradition gives way to a monument of pure, staggering mass. In the Bekaa Valley of Lebanon, the ruins of the Roman temple complex of Baalbek hold a foundation that defies belief. Beneath the grand columns lies a platform, and within that platform are 3 stones known as the Trilithon. Each one is a leviathan of limestone, measuring roughly 64 feet long, 14 feet high, and 12 feet deep. Their weight is almost incomprehensible, an estimated 800 tons apiece. To put that in perspective, each stone equals the mass of 2 fully loaded Boeing 747 jumbo jets. They are among the largest single pieces of stone ever quarried and moved by human hands in all of history. The Romans, master builders of the ancient world, are credited with this feat, constructing the Temple of Jupiter here nearly 2,000 years ago. But the sheer physical reality of the Trilithon pushes the very limits of that credit. The engineering puzzle is twofold, a mystery of transport and a mystery of placement. First, these blocks were cut from a quarry located over half a mile away. Moving an 800-ton stone even a few inches on flat, prepared ground would be a Herculean task today, requiring specialized machinery. Transporting it across uneven terrain for thousands of feet seems almost fantastical. Theories suggest they may have been moved on a sled greased with animal fat, pulled by thousands of workers or possibly oxen, rolling on a track of wooden logs. Yet the friction, the risk of the logs crushing under the weight, and the sheer coordination required boggle the mind. The second, even greater challenge was the lift. These stones were not simply laid on the ground. They were raised over 20 feet in the air and set into the platform's wall with such precision that the joints between them are razor thin. How do you lift something that heavy to that height without a modern crane? The most plausible explanation involves an enormous earthen ramp built up to the desired level. The stone could then be dragged slowly up this incline, a process requiring immense counterweights, levers, and an ocean of patient labor. Once in position, the ramp would be dismantled. Yet, even this accepted theory feels inadequate. The scale of the ramp needed for such an operation would itself be a monumental construction project. The logistics of feeding, housing, and organizing the workforce for what would have been a project spanning decades are staggering to contemplate. This leads to the haunting core of the puzzle. The Romans were brilliant engineers, but the Trilithon exists at the very outer edge of what their documented technology should have allowed. It stands as a silent testament to a level of ambition and logistical mastery that borders on the superhuman. Was this the pinnacle of known Roman technique, a one-time, all-out effort to create something truly godlike in scale? Or does its existence hint at a method, a clever application of physics, or a forgotten piece of engineering technology that has been lost in the centuries since? The stones do not speak, but their immense presence asks a relentless question. How much are we still underestimating the practical problem-solving of the ancient world when it was driven by an unwavering collective will? The immense earthbound stones of Baalbek give way to a mystery that lies entirely beneath the waves. Off the western tip of Japan's Yonaguni Island, in the clear blue waters of the Pacific, a structure emerges from the seabed that refuses to be easily categorized. Known as the Yonaguni Monument, it is a colossal formation of sandstone rising over 80 feet from the ocean floor. What you see is not a random pile of rock. The structure displays a breathtaking array of geometric features, sharp right angles, perfectly straight terraces, clean staircases, and what appear to be wide, flat platforms. It looks for all the world like the ruins of a sunken city, a vast ceremonial complex or fortress swallowed by the sea. This visual impression is so powerful that it immediately presents us with a profound and binary question. Is this the work of human hands, or is it a spectacular geological accident? The debate that surrounds Yonaguni is one of the purest examples of our list's theme, a direct clash between what our eyes interpret and what conventional history permits us to believe. Geologists point to the region's unique sandstone, which naturally fractures along straight lines and flat plains due to tectonic stress. They argue that the powerful underwater currents have eroded the stone along these natural joints, sculpting the steps and platforms over millennia through entirely natural processes. In this view, Yonaguni is a masterpiece of chance, a stunning example of what nature can create when given the right materials and enough time. Yet, for those who see human design, the sheer accumulation of regular features is the puzzle. One right angle could be a coincidence, a series of them aligned with each other, coupled with what looks like a ceremonial archway and twin monoliths that seem placed with intention, stretches the limits of natural explanation. The most compelling argument for a human origin, however, comes not just from the shapes but from the timeline. Research into ancient sea levels suggests this structure was last above water around 10,000 years ago, at the end of the last ice age. This date is the true seismic shock to our historical narrative. If human builders are responsible, it places the creation of Yonaguni in a prehistoric era known to archaeologists as the Jomon period in Japan. The Jomon people are recognized for their sophisticated pottery and settled communities, but not for monumental stone architecture on this scale, and certainly not for being a seafaring culture capable of such complex underwater construction, if it was built when the site was dry. This single fact transforms Yonaguni from a curious underwater formation into a potential paradigm-shifting anomaly. It forces us to confront a haunting possibility. Could there have been a culture, now lost to the rising seas, that possessed engineering knowledge we have not yet attributed to that distant epoch? The monument sits in a liminal space, both physically and intellectually, between the solid ground of established geology and the deep waters of archaeological mystery. To dive at Yonaguni is to swim through a question where every straight edge is a clue, and the answer depends entirely on whether you believe the human story is longer and more complex than the one currently written in our textbooks. The geometric perfection we sense at Yonaguni becomes undeniable, even tactile, at our next site. In the high plains of Bolivia, near the shores of Lake Titicaca, lie the ruins of Pumapunku. This place does not feel like a construction site abandoned by ancient builders. It feels like a factory floor where the machines suddenly vanished, leaving behind a scattered inventory of impossible components. Primary material is andesite, a volcanic stone as hard as granite. Yet the stones themselves are anything but crude. They are modular, interlocking blocks, many in a distinctive H shape, and they are carved with a precision that stops the breath. The surfaces are flawlessly flat, meeting at crisp 90-degree angles. You can find perfectly straight grooves cut as if by a modern router, and drill holes that are cylindrical and uniform. Some blocks have complex, recessed channels and notches that look less like chisel work and more like the output of a computer-controlled milling machine. The visual effect is profoundly anachronistic. This is stone that appears to have been worked with industrial tools, not with the simple copper chisels and hammerstones that mainstream archaeology tells us were available to the Tiwanaku culture over 1,000 years ago. That is the heart of the engineering puzzle. How do you achieve a mirror-smooth finish on a stone this hard with a soft copper tool? Copper is significantly softer than andesite. Using it to chip or abrade the stone would be like trying to carve a brick with a stick of butter. It simply would not work in any efficient way. The standard explanation involves the use of abrasives like quartz sand, which is harder than the andesite. The theory suggests that by rubbing sand between a copper saw or drill and the stone over immense periods of time, you could slowly grind it down. This is plausible for simple shapes, but the precision at Pumapunku pushes this idea to its breaking point. How do you maintain a perfectly straight groove, 60 centimeters long, with such a method? How do you drill a hole with such consistent diameter without the drill bit wandering? How do you mass-produce dozens of these identical, complex H-blocks with such repeatable accuracy? The scale of production here suggests not a one-off artistic achievement, but a systematized process. It hints at specialized tooling, perhaps frames or jigs to guide cuts, and a sophisticated understanding of material science. Some researchers have even pointed to the possibility of lost techniques, like the use of plant-based acids to soften the stone surface temporarily for working, though evidence remains elusive. The enigma of Pumapunku is not about moving mountains, but about mastering material at a microscopic level. It forces a difficult question: did the builders possess a level of technical knowledge, a suite of tools and methods that has left no trace in the archaeological record besides the stones themselves? These silent, geometric blocks are the ultimate tease. They show us a capability without showing us the means, leaving us to wonder if we have truly uncovered all the tools of the ancient world, or only the ones that were simple enough to be left behind. The geometric perfection of Pumapunku represents a mastery of stone, but what happens when an entire civilization decides to move not just stone, but the earth itself, and then vanish without a word? In 1992, in the Chinese province of Zhejiang, a local farmer decided to pump the water out of a small, deep pond in his village. What he revealed was not a natural sinkhole, but the entrance to an artificial wonder. The Longyou caves are not a single chamber. They are a vast, hidden complex of 24 colossal caverns, each one painstakingly carved by hand from solid sandstone. The scale is almost impossible to internalize. Together, they cover an area of over 30,000 square meters, with the largest single cave soaring over 100 feet high and spanning an area larger than a cathedral. The volume of rock removed is staggering, estimated at nearly 1 million cubic meters. To put that in perspective, that is enough stone to build 30 great pyramids of Giza. This was not a quarry where material is simply extracted. This was architecture in reverse, a deliberate act of sculpting immense, ordered space from the living rock. Every surface tells a story of immense, coordinated labor. The ceilings are supported by enormous, uniformly carved pillars, positioned with clear structural intent to hold up the unimaginable weight above. The walls and ceilings are covered from floor to ceiling in a mesmerizing pattern of parallel chisel marks, each struck at a precise 60-degree angle. This consistent angle is not decorative whimsy. It is the signature of a systematic, taught technique applied by thousands of workers over what must have been generations. And this is where the mystery deepens from an engineering feat into a historical ghost story. The how is bewildering. How did they illuminate such deep, vast spaces to work with such uniformity? Where did they put the nearly 1 million cubic meters of rubble they removed, an amount that would form a small mountain without leaving a single trace in the surrounding landscape? But the more profound puzzle is the why and the who. Despite their staggering scale and obvious sophistication, the Longyou caves are absent from any historical record, any local legend, or any folk memory. No scroll, no poem, no dynastic history mentions their construction. They were simply forgotten, as if the thousands of people who must have worked there, and the society that commanded such a project, agreed to never speak of it again. This makes them perhaps the purest ghost project of the ancient world. An endeavor of this magnitude implies a powerful, centralized authority with vast resources and a very clear purpose. Were they imperial tombs that were never used? Were they secret reservoirs or storage facilities for a kingdom preparing for a crisis that never came? Or did they serve a ritual purpose so profound that their very existence was considered a secret not to be recorded, only to be known by the initiated? The caves offer no inscriptions, no artifacts, no bones, no clues. They are a hollow monument to a collective act of forgetting. They stand as a silent testament to a truth that unnerves historians, that a civilization can undertake one of the most massive engineering projects on Earth and then simply walk away, allowing the waters to rise and memory to fade, leaving behind only a vast, empty space and a question that echoes in the dark. The ghostly silence of the Longyou caves gives way to a monument that speaks in a different, more elemental language, the silent defiance of metal against time. In the heart of Delhi, India, stands a 7-meter-tall iron pillar erected around the year 400. For over 1,600 years, it has endured monsoons, scorching heat, and urban pollution. Yet, while modern steel structures around it show the familiar orange-brown scars of corrosion, this ancient pillar remains remarkably untouched. Its surface is smooth, bearing only a dark, protective patina. It has not rusted in the way that science and common experience tell us it absolutely should. This is not a matter of luck or dry climate. It is a metallurgical mystery cast in iron. When modern scientists finally analyzed a small sample, they discovered the pillar's secret. It is made of astonishingly pure wrought iron with a very low carbon content. But the real magic lies in a thin, invisible barrier, a protective film on the surface just 1/20th of a millimeter thick. This film is not an applied coating, it formed naturally. It is a crystalline layer of a compound called iron hydrogen phosphate. This shield acts as a passive barrier, preventing oxygen and moisture from reaching the raw metal beneath and initiating the destructive chemical reaction we know as rust. The discovery of this layer presents us with a classic ancient engineering puzzle, one of intent versus accident. Did the blacksmiths of the Gupta Empire, through a fortunate combination of materials and method, accidentally create this perfect anti-corrosive shield? The iron they used came from a type of ore that was naturally high in phosphorus. Their unique forging technique, which involved hammering and welding together many small pieces of hot iron rather than casting a single molten mass, may have distributed this phosphorus in just the right way. Over centuries, the phosphorus reacted with the iron and the environment to slowly build that perfect protective skin. In this view, the pillar is a magnificent accident, a happy convergence of material and craft. The alternative theory, however, is far more provocative. It suggests these ancient metalworkers possessed a sophisticated, deliberate understanding of their materials. Could they have known that using high phosphorus ore and their specific forging process would yield a metal capable of lasting millennia? Did they conduct, through generations of trial and observation, a form of empirical materials science that we are only now able to reverse engineer with electron microscopes and X-ray diffraction? This pillar stands as a direct challenge to the smooth narrative of incremental technological progress. It represents a peak of practical metallurgy that was not surpassed for centuries, and its secret was effectively lost. It forces us to reconsider the depth of knowledge contained within ancient craft traditions, knowledge often passed down not in textbooks, but in the hands of the artisan, in the heat of the forge, and in the careful selection of stone from a particular mine. The Iron Pillar of Delhi is more than a relic. It is a testament to a forgotten chapter in humanity's long dialogue with the elements, a dialogue where the answer to the problem of decay was not just found, but literally forged into being. From the enduring strength of forged iron, we move to a canvas of unimaginable scale, where the art is the landscape itself. The Nazca lines of Peru transform 450 square miles of arid desert into the world's largest and most mysterious sketchbook. These are not small carvings. They are geoglyphs, massive designs created by removing the dark, oxidized surface stones to reveal the lighter sand beneath. From ground level, they appear as shallow, wandering pathways, but from the air, the truth reveals itself. The lines coalesce into staggering images: a hummingbird with a beak longer than a football field, a spider with legs that stretch for blocks, a monkey with a spiraled tail, and geometric shapes so vast they seem to map the territory of giants. The immediate, visceral question is the most obvious one: why create art you cannot see? The cultural and spiritual purpose, likely tied to rituals for water and fertility in an extremely dry region, is a profound mystery in itself. But for our investigation, the engineering puzzle is equally compelling. How did they achieve such precision on this colossal scale without ever taking flight? The Nazca people, flourishing between 200 before the Common Era and 600 after, had no balloons, no kites substantial enough for a human observer, certainly no aircraft. Their entire perspective was from the dusty plain, looking across a confusing network of trenches. The prevailing archaeological explanation is elegant in its simplicity. They could have used a system of stakes and ropes. By establishing a central axis line and a scaled-down model, perhaps laid out on a smaller hillside, they could transfer the design point by point to the desert floor using a grid system. A team with long ropes and aligned sighting poles could then extend perfectly straight lines for miles, using the clear desert air and distant mountain peaks as fixed reference points. This method is demonstrably possible, and it highlights remarkable skill in surveying and collective labor. Yet, when you stand before the actual figures, this explanation can feel incomplete. The scale is one thing, but the fluid, graceful proportions of the animal figures are another. The hummingbird's curved beak, the spider's delicate legs, the monkey's perfectly formed spiral, these are not just straight lines. They are continuous, flowing curves executed with a draftsman's confidence across hundreds of meters of uneven ground. Maintaining the artistic integrity of such a complex shape over that distance, where a small error in angle at the start becomes a huge deviation at the finish, is a problem of geometry and coordination that still gives modern engineers pause. It suggests the Nazca possessed not just simple surveying skills, but a sophisticated, embodied understanding of scale and form. They may have thought in ratios and relationships, translating a mental or small-scale template into a terrestrial monument through a perfected communal technique. This points to a society with an extraordinary capacity for shared vision and disciplined execution, where hundreds of workers moved in concert, guided by a plan they could only fully comprehend as a collective act of faith. The lines, therefore, are more than art or ritual pathways. They are the physical manifestation of a shared idea, a testament to what a community can create when every member understands their precise role in a pattern too large for any single person to see. They challenge us to expand our definition of engineering beyond machinery, to include the profound human engineering of social coordination and transmitted knowledge, proving that to alter the face of the earth, you sometimes only need a plan, a rope, and a unified sense of purpose. That profound sense of a shared, unseen pattern finds an even deeper resonance when we step into the earth itself. Beneath the streets of Paula, Malta, lies a sanctuary carved from solid limestone, a place known as the Hypogeum of Saflieni. This is not a cave, but a three-level subterranean temple complex, painstakingly excavated over centuries by a Neolithic culture over 5,000 years ago. Its chambers and halls form a labyrinth of spiritual space, a monument to the dead and perhaps a theater for the living. But this ancient site holds a secret that is not seen but heard. Within its enclosed spaces, sound behaves in extraordinary ways. The Hypogeum possesses a remarkable and potentially intentional acoustic property. Specific chambers resonate powerfully at certain low frequencies, particularly around 110 Hz, a tone within the range of a deep male voice. When a person speaks or chants in these resonant spaces, something strange happens. The sound is amplified and distorted, filling the room with a palpable vibration that seems to come from everywhere and nowhere at once. It can create an immersive, otherworldly auditory experience where the boundary between the self and the sound blurs. For a culture engaged in ritual and ceremony, the implications are profound. This acoustic effect could have been used to induce altered states of consciousness, to make a priest's voice sound like the voice of an ancestor or a deity, or to create a shared sensory experience that bonded the community in awe. This moves our investigation from the physics of stone and metal into the more elusive realm of sensory engineering. The puzzle here is one of knowledge versus intuition. Could the builders of the Hypogeum, working millennia before the science of acoustics was formalized, have intentionally designed these chambers to produce these specific sonic effects? Creating such a space without any modern tools for sound analysis seems almost impossible. It would require either an incredibly sophisticated, experimentally derived understanding of how sound waves interact with enclosed spaces of specific volumes and shapes, or an intuitive, generational knowledge passed down through trial and observation. Perhaps they discovered through accident that a chamber of a certain dimension created a powerful echo, and then they refined that design over generations, sculpting the limestone to perfect the resonance. This suggests a cultural priority where the experience of sound was as important as the visual symbolism of the carvings on the walls. The Hypogeum, then, becomes more than an ancient tomb. It becomes a kind of architectural instrument, a device crafted from the living rock to orchestrate human emotion and perception. It hints at a level of holistic design where spirituality, architecture, and an understanding of natural phenomena were woven into a single, profound practice. To stand in the oracle chamber and speak is to participate in a 5,000-year-old experiment, one that challenges our assumption that ancient builders were concerned only with form and function. They may have been masters of atmosphere, engineers of experience, using the very voice of the earth to shape the human spirit. The architectural instrument of the Hypogeum required a mastery of sound within stone, but to shape the stone itself on a truly colossal scale demanded a different kind of symphony, one of logistics, force, and breathtaking ambition. Ancient Egypt's obelisks are the ultimate expression of this ambition, turning geology into towering symbols of power that reached for the sun itself. These were not built from blocks. Each obelisk was a single, slender needle of red granite, quarried as a monolith weighing up to 500 tons, then transformed into a gleaming monument capped with electrum to catch the first light of dawn. The engineering puzzle unfolds in three distinct, equally daunting acts: quarrying, transport, and the final, heart-stopping lift. The process began in the quarries of Aswan, where workers used simple dolerite pounders to painstakingly define the shape of the obelisk directly in the living bedrock. They would carve deep trenches around its perimeter, undercutting it until it lay free on a bed of stone, a sleeping giant awaiting its journey. The unspoken question here is one of control. How do you ensure a 200-foot-long stone beam does not crack under its own immense weight during this delicate liberation? The answer was likely a combination of perfect geometry and patient, meticulous work. Once free, the real test began. The obelisk was dragged on a massive sledge to the banks of the Nile, a journey involving thousands of laborers, miles of lubricated timber tracks, and a coordination that must have resembled a slow, deliberate dance. At the river, it was loaded onto a specially built, enormously wide barge to ensure stability, and then the current and sails carried it hundreds of miles downstream to its destination. This riverine leg was a feat of naval architecture in itself, moving a skyscraper of stone on the water without capsizing. But the climax of the operation, the moment that separates theoretical planning from sheer audacity, was the erection. Ancient depictions show the use of a giant earthen ramp leading up to a sand-filled pit at the temple entrance. The obelisk, still on its sledge, would be dragged up this ramp until its base was positioned directly over the pit. Then, with ropes controlling its descent, the sand was slowly emptied from the pit, allowing the monolith to pivot downward, its base sinking into a prepared foundation as its towering length rose majestically toward the sky. The margin for error was zero. A slip in the rope teams, an uneven release of sand, a hidden flaw in the granite, and the obelisk would shatter, representing a catastrophic loss of years of labor and a profound spiritual failure. This final act was not just engineering, it was theater, a public demonstration of the pharaoh's command over both nature and society. It required an intuitive, profound understanding of leverage, center of gravity, and mass distribution that modern engineers still analyze with deep respect. While we understand the broad principles, the practical execution on this scale, with the tools and time available, remains a subject of awe. It stands as a testament to what is possible when human will, organized on a civilization scale, is directed toward a single, luminous point in stone. The same drive to impose perfect geometry on the natural world appears again, not in the lines of a desert, but in the pure, solid form of a sphere. Deep in the jungles of Costa Rica, workers clearing land in the 1930s uncovered something utterly unexpected. Hundreds of stone spheres, some as tall as a person, resting silently in the earth. Crafted by the Dikwis culture over 1,000 years ago, these objects are a study in focused perfection. They are carved from gabbro, a hard, dense, igneous rock, and their sphericity is astonishing. Many are so perfectly round that modern measurements reveal deviations of less than 2% from a true sphere, a level of accuracy that rivals precision machining. Their surfaces are flawlessly smooth, polished to a high sheen that has endured centuries of tropical weather. The immediate, tactile puzzle is the how. How did a pre-Columbian culture, using stone hammers and other simple tools, achieve such geometric purity in a material this unforgiving? The accepted theory involves a multi-step process of controlled fracture and patient abrasion. First, a large boulder would be roughly shaped by heating it with fire and then dousing it with water, causing layers to crack and flake away. Then, with stone mauls, the form would be gradually pecked into a rough sphere. The final, most demanding stage was the polishing, likely achieved by grinding the sphere with sand and water, possibly while it was rotated in a bed of other stones or sand. This explanation is logical, but when you stand before a 2-meter diameter sphere weighing over 15 tons, its surface as smooth as river stone, the sheer scale of the labor becomes the true mystery. This was not a quick artistic endeavor, it was a generational project of relentless communal effort for each sphere. The deeper, more haunting layer of the puzzle, however, is not their creation but their purpose. Their original arrangement is lost to us. When discovered, many had been moved from their ancient positions by later agricultural activity. Archaeologists believe they were once placed in alignments, perhaps in the plazas of important settlements or along pathways leading to the homes of leaders. Some suggest they functioned as astronomical markers or symbols of celestial bodies, while others see them as potent status symbols, embodiments of power and communal identity. Their perfect shape may have held deep cosmological meaning, representing unity, the sun, the moon, or the very ideal of completion. This transforms them from mere artifacts into profound questions. They represent a civilization's immense investment of time and energy, not in a temple or a fortress, but in the pursuit of an abstract ideal, geometric perfection. They are a solved technical process that has since been forgotten, a testament to a culture that could master stone not to build walls, but to create silent, polished orbs whose only message is their own flawless existence. In their quiet perfection, they ask us what we value enough to shape over generations, and what of our own ideals might one day be found, perfectly formed but utterly unexplained, by those who come after. That pursuit of perfection in stone gives way to a material that mastered the sea itself. While modern engineers battle the relentless corrosion of ocean water, the ancient Romans built harbors that have defied it for 2 millennia. At the port of Caesarea and other maritime sites, submerged concrete structures do not simply endure, they thrive, growing harder with each passing century. This presents a direct and humbling comparison. Modern Portland cement concrete, the backbone of our civilization, begins to crack and weaken in saltwater within decades, requiring constant and costly repair. The Roman version, by stark contrast, has survived 2,000 years of waves and salt, emerging not as a crumbling relic, but as a testament to a forgotten recipe. For the longest time, this durability was a complete mystery, a quiet victory of ancient material over modern science. The breakthrough came when researchers finally analyzed core samples from a Roman pier under an electron microscope. What they found was a microscopic world of brilliant chemistry. The Romans used a mix of volcanic ash from a source called pozzolana and lime. When this mixture was combined with seawater and poured into wooden forms, it initiated a slow, complex chemical conversation. Over decades and centuries, the seawater percolating through the concrete reacted with the ash and lime to form a rare, plate-like mineral called aluminous tobermorite. This mineral does not just fill space, it strengthens the matrix from within, making the concrete more dense and more resistant to fracturing over time. Even more remarkably, if a crack does begin to form, incoming seawater can react with the surrounding material to form new crystalline structures, effectively healing the wound. This is a self-repairing material, a concept modern materials scientists are still striving to achieve in the lab. The engineering puzzle here is not one of scale or precision, but of intent. Was this miraculous property a deliberate innovation, the result of centuries of empirical trial and observation by Roman engineers who meticulously noted which local materials yielded the longest-lasting harbors? Or was it, more likely, a magnificent accident? The Romans used what was locally available, volcanic ash and lime, and the unique mineral-rich seawater of the Mediterranean did the rest, performing a chemistry experiment over geologic time that they themselves could never have fully understood. This distinction lies at the heart of so many ancient wonders. It asks us whether we are looking at applied science or at the profound, unintended consequences of using natural materials in harmony with their environment. The Roman concrete does not answer this question, it simply persists, a silent, strengthening monument to a possibility that sometimes the most advanced solution is not invented but discovered, one wave at a time across centuries. While Roman concrete mastered the chemistry of the sea, high in the Bolivian Andes another stone monument mastered the mathematics of the sky. The Gateway of the Sun at Tiwanaku stands alone, a solitary 10-ton portal carved from a single, immense block of andesite. It is not its size, however, that defines its mystery, but the story etched across its surface. The gateway is a library in stone, its face dominated by a central deity figure often called the staff god, surrounded by 48 smaller, winged figures that seem to be running toward him in 2 converging rows. For decades, researchers have studied this intricate iconography, and many have come to believe it encodes a complex calendar system, a sophisticated method of tracking solar and lunar cycles, agricultural seasons, and ceremonial dates. The precision of this low-relief carving is remarkable, each figure crisply defined in the unforgiving stone. Yet this celestial puzzle is framed by a far more earth-bound one. The true engineering enigma of the gateway is not what is carved on it, but how it arrived at Tiwanaku in the first place. The andesite block was quarried from a site over 50 miles away, across the harsh, windswept terrain of the Altiplano, a high plateau sitting over 12,000 feet above sea level. Here, the Tiwanaku culture flourished without the wheel, without draft animals like horses or oxen, and with a limited supply of timber. Moving a single 10-ton stone that distance under those conditions is a logistical equation that seems to defy solution. The challenge of high altitude adds a critical, often overlooked layer. At that elevation, the air is thin, making any sustained physical labor exponentially more exhausting. The workers themselves would have needed to be acclimatized from birth, but the sheer caloric demand of such an operation is staggering. How do you feed and sustain the large teams required to drag a monolithic slab for weeks across a rocky plain, when every step requires more effort and every breath delivers less oxygen? The prevailing theory, as with so many megalithic puzzles, involves a combination of manpower, ropes, and sledges, perhaps sliding on a track of smoothed mud or lubricated logs. But the distance transforms this from a difficult task into an epic of endurance and coordination. It suggests a society capable of extraordinary long-term planning and social cohesion, where the value of bringing this specific stone from that specific quarry outweighed the monumental effort required. The gateway, therefore, becomes a symbol of two different kinds of mastery. Its face reveals a mastery of cosmic order and timekeeping, an intellectual architecture carved in rock. Its very presence at the site, however, testifies to a mastery of human will and logistical organization, a physical architecture of community effort. One represents the mind of Tiwanaku, the other its muscle and spirit. Together, they form a complete puzzle, asking us not only how they understood the heavens, but how they moved mountains to inscribe that understanding in a doorway that leads quite literally nowhere, yet seems to open onto the entire cosmos. The profound community effort that raised the gateway of the sun finds its ultimate expression not in a monument to the sky, but in a refuge carved deep within the earth. Buried beneath the rolling plains of Cappadocia in Turkey lies Derinkuyu, an ancient subterranean city of breathtaking scale and complexity. This was not a simple cave network or a temporary hiding place. It was a fully realized, self-contained metropolis built downward, capable of sheltering an estimated 20,000 individuals for extended periods. The scale alone is staggering, a labyrinth extending over 200 feet deep, encompassing at least 8 excavated levels, with some researchers believing there are more still buried. But the true engineering marvel lies not in its depth, but in its meticulous design for sustainable life. The builders, likely beginning in the early first millennium, faced a unique geological opportunity and a profound challenge. The region's soft volcanic tuff was relatively easy to carve, yet inherently unstable for large-scale excavation. The first puzzle was structural integrity. How do you prevent a multi-story underground city from collapsing under its own weight? The solution reveals a sophisticated understanding of load-bearing architecture. They left massive, strategically placed rock pillars to support ceilings, carved arched doorways and rounded rooms to distribute stress, and designed narrow, winding corridors that reinforced the surrounding stone. This was architecture in reverse, a careful subtraction of material that left behind a stable, honeycombed fortress. The second, and perhaps more brilliant, puzzle was environmental systems. Sealing the entrance meant sealing in a population of thousands, along with their livestock, food, and waste. Without constant fresh air, the atmosphere would quickly become toxic. Without a reliable water source, survival would be impossible. The engineers of Derinkuyu solved this with elegant ingenuity. Over 50 ventilation shafts, some descending the full depth of the city, provided a constant flow of fresh air to even the lowest chambers. These were not simple holes, but carefully engineered ducts that utilized natural convection currents, drawing stale air up and out while pulling fresh air down from the surface. Deep wells tapped into the underground water table, providing a secure supply independent of surface sources. They even engineered a complex network of channels for waste management. This points to a level of civil engineering planning that rivals modern urban design, all conceived for a community living in perpetual twilight. The purpose of Derinkuyu is clear from its defensive features: massive, circular stone doors that could roll shut to block passages, and its sheer hidden nature. It was a refuge from invasion, a place where an entire regional population could vanish from the surface world until danger passed. This transforms it from a mere shelter into a profound social artifact. It represents the ultimate investment in collective security, a generations-long project born from a harsh reality of conflict. The city is a testament to a society that chose to dig in rather than flee, to engineer resilience directly into the landscape. It challenges our notion of ancient urban planning, showing that the greatest architectural feats are not always those that reach for the heavens, but sometimes those that delve into the earth to protect the very heartbeat of a community. Deep beneath the green hills of Wales lies a network of tunnels so ancient it rewrites the story of industry itself. The Great Orme copper mines are a sprawling subterranean world, a labyrinth carved by hand over 4,000 years ago during the Bronze Age. The sheer physical output of this place is the first staggering fact. Over centuries of operation, miners here extracted an estimated 1,800 tons of copper ore. To visualize that, picture a line of modern dump trucks, each loaded to capacity, stretching for miles. This was not a small-scale, seasonal operation. This was a major industrial enterprise in an era we often picture through simple tools and scattered villages, and the tools themselves heighten the mystery. These miners worked with implements made of stone, bone, and antler. They had no metal picks, no iron chisels, no dynamite. Using hammerstones and wedges made from animal bone, they painstakingly fractured the solid rock, following rich seams of green copper ore deeper and deeper into the earth. The tunnels they left behind are a maze covering over 5 miles, with some shafts plunging 230 feet below the surface. Venturing into these narrow, twisting passages today, with only the light from a modern lamp, is a humbling and slightly claustrophobic experience. You are walking in the literal footsteps of individuals who worked by the faint, flickering light of animal fat lamps, in air thick with dust and the constant fear of a cave-in. This fear leads us to the first layer of the engineering puzzle, which is one of safety and structural foresight. The miners of the Great Orme were not just diggers, they were underground architects. They developed a sophisticated system of timbering, using wooden props and beams to reinforce the ceilings of the larger chambers and stopes where ore was removed. This was proactive engineering, an understanding that to extract the resource, they first had to ensure the mountain would not collapse upon them. It speaks to a hard-won, generational knowledge of rock mechanics and support, learned through tragic trial and error and then systematically applied. The second, even more profound puzzle is one of organization and logistics. Mining on this scale is not a solitary activity. It requires a coordinated society. Who organized the labor crews, each with specialized roles from breaking rock to hauling ore to maintaining the timber supports? How was the ore processed once it reached the surface, requiring furnaces and skilled smelters to transform rock into usable metal? And then, most intriguingly, how was this copper traded? The finished metal from the Great Orme has been found in artifacts across Britain and even into continental Europe. This implies established trade routes, a network of exchange, and a value system that connected this remote Welsh hillside to a wider Bronze Age world. This level of coordination, extraction, processing, distribution points to a society with remarkable resource management and long-term planning. It challenges the simplistic view of early metallurgy as a scattered, almost accidental craft. Instead, we see the outlines of a structured industry, a community that understood supply chains and specialization millennia before the term was invented. The quiet, dark tunnels of the Great Orme force us to replace our image of the prehistoric miner with a more complex reality, that of a skilled worker in a vast, organized system, whose labor in the eternal dark helped to build the gleaming Bronze Age world above. The dark, organized industry of the Great Orme mines gives way to a discovery that lies not within rock, but beneath the waves where sound paints a picture of a lost world. In the early 2000s, marine archaeologists surveying the Gulf of Khambhat off India's western coast made a startling announcement. Their sonar scans had detected what appeared to be large, geometric patterns on the seabed, over 100 feet below the surface. The images suggested not random debris, but the outlines of structures, grids that resembled streets, and even what looked like artifacts. The depth was the crucial clue, pointing to a time when this area was dry land, potentially over 9,000 years ago. If these sonar shadows were indeed the work of human hands, their implications would be seismic, challenging the very foundations of our historical timeline. This discovery ignites one of the most intense debates in modern archaeology, a perfect storm of tantalizing evidence and profound skepticism. The central question is brutally simple. Are we looking at the sunken ruins of a prehistoric settlement, or are we seeing the remarkable handiwork of nature, a collection of geological formations that happen to mimic human design? The natural explanation is compelling. Ocean currents, tidal erosion, and the settling of sediments can create astonishingly regular patterns on the seafloor. Ancient river channels, now submerged, can leave behind linear features that look unnervingly like roadways or foundations. Without physical proof pulled from the murky depths, the sonar images remain ambiguous, a Rorschach test projected onto the ocean floor. Yet, for those who argue for a human origin, the potential scale is the puzzle. A settlement large enough to leave such a sonar signature would represent a complex, organized society thriving millennia before the rise of the Indus Valley civilization, long considered the cradle of Indian urban life. This would not just push back the clock, it would suggest an entirely different chapter of human development in the region, one that flourished on coastal plains now drowned by the rising seas at the end of the last ice age. The controversy is less about the existence of ancient people and more about the scale and sophistication of their communities. Could there have been early centers of culture and innovation that were completely lost when the shorelines retreated? This possibility forces a humbling perspective shift. We have mapped the surfaces of other planets in greater detail than our own ocean floors. The Gulf of Khambhat, whether its formations are natural or artificial, serves as a powerful symbol for all that might be hidden. It raises a profound, almost philosophical question about the completeness of our story. How much of humanity's early journey was written on coastal shelves and river deltas that are now eternally underwater? The search for answers there is a battle against time, tides, and shifting silt, a reminder that some of our greatest historical mysteries may lie in the silent, dark world beneath the waves, waiting for technology and patience to bring their secrets to light. While the debate over sunken cities rages in sonar shadows, a different kind of mystery emerged from the mud of European rivers, one forged in fire and wielded in battle. Between the 9th and 11th centuries, a name began to appear on the blades of swords that chilled the hearts of those who faced them: Ulfberht. These were not ordinary weapons of the Viking Age. When a modern metallurgist analyzes an Ulfberht sword, the results are shocking. The blade is made of a type of steel so advanced, so pure, that it should not have existed in Europe for another 800 years. This is crucible steel, a material with an exceptionally high and uniform carbon content and almost no slag, the brittle impurities that made contemporary swords prone to shattering. The process to create it required a furnace capable of reaching temperatures over 3,000 degrees Fahrenheit, hundreds of degrees hotter than what European blacksmiths of the time could typically achieve. The resulting metal was stronger, more flexible, and could take a sharper, more durable edge than anything else on the medieval battlefield. It was, in essence, a technological singularity in the form of a sword. The inscription itself, plus ULFBERHT plus, stamped into the blade, was not a maker's signature in the personal sense. It was a brand, a mark of guaranteed quality and fearsome reputation that spread from Scandinavia to the frontiers of the Frankish Empire. But this brand only deepens the mystery. Who or what was Ulfberht? Was it a master smith, a guild, a dynasty of armorers, or perhaps the name of the workshop itself, a medieval corporation guarding the secret of its process? The leading theory that attempts to solve this metallurgical puzzle points not north but south and east, along the vast river trade routes that connected the Viking world to the Abbasid Caliphate. In regions like modern-day Iran and Central Asia, smiths had mastered the art of creating crucible steel, known as Damascus steel or fulad, in specialized furnaces. This knowledge was a closely guarded treasure of the Islamic world. The puzzle, then, is one of transmission. How did this high-temperature, high-tech process, or more likely, the finished steel ingots themselves, travel thousands of miles to the forges of the north? The answer lies in the Vikings' role as the premier traders and middlemen of their age. They navigated the river systems of Eastern Europe, reaching markets in Baghdad and Constantinople, trading furs, amber, and slaves for silver, silks, and other luxuries. It is entirely plausible that among these treasures were bars of this miraculous steel, acquired at great cost. A Viking chieftain or wealthy warrior would have prized such material above almost anything else, for it conferred not just wealth but supreme advantage in conflict. The true engineering feat, however, may have been local. While the raw material might have been imported, the skill to work it resided with the Ulfberht smiths themselves. Forging a sword from this steel required a master's touch, an intuitive understanding of heat and hammer that transformed an exotic ingot into a legendary weapon. This suggests a secretive, centralized production, perhaps in a single workshop or a tightly knit family of smiths who controlled the knowledge for generations. Their success created a paradox: weapons of almost mythical quality, born from a global trade network, yet wielded in an era we often wrongly think of as isolated and dark. The Ulfberht swords stand as metallic proof that ancient engineering breakthroughs could travel, that innovation was a commodity as valuable as silver, and that the quest for a perfect blade could connect worlds separated by continents and culture, leaving behind a legacy sharp enough to cut through the fog of 1,000 years. The global trade routes that delivered the secret steel of Ulfberht connect to a far more intimate and modern mystery, one built not by an empire but by a single, solitary heart. In the humid landscape of 20th century Florida, a Latvian immigrant named Edward Līdzkalnis began a quiet, decades-long project fueled by personal sorrow. After a failed engagement, he dedicated his life to constructing what he called the Coral Castle, a sprawling complex of massive stone sculptures and structures carved from Ulitic limestone. The scale of his solitary work is the first layer of the puzzle. Līdzkalnis single-handedly quarried, shaped, and positioned over 1,100 tons of rock. The individual blocks are staggering, with the largest weighing 30 tons, a mass equal to a full-grown humpback whale. He accomplished this without modern machinery, without large teams of workers, and almost entirely under the cover of night, shrouding his methods in deliberate secrecy. When pressed by the rare curious visitor, he would offer cryptic explanations, claiming he had rediscovered the secret of the pyramids, that he understood the laws of weight and leverage used by the ancient builders. He spoke of harnessing magnetic currents and understanding the principles of anti-gravity, knowledge he said was possessed by the builders of antiquity. These claims, combined with the sheer physical improbability of one man moving such mass, ignited endless speculation. Could a lone individual have stumbled upon a forgotten principle of physics, a way to negate or dramatically reduce weight? The more grounded and widely accepted explanation points to simple genius rather than supernatural secrets. Lidskalnin was a master of leverage, pulley systems, and block and tackle. Photographs from the time show he possessed a collection of simple tools, tripods, chain hoists, and homemade winches. With enough mechanical advantage, a single person can move astonishing weight, inch by patient inch. He likely used a system of pivots and fulcrums, raising stones with tripods and then carefully walking them into position with a slow, rocking motion. The true engineering marvel, then, may not be in defying physics, but in his profound mastery of its most fundamental laws. He understood center of gravity, pivot points, and friction in an almost intuitive, embodied way. He turned basic principles into a silent, one-man ballet of stone. Yet, the enduring power of the coral castle as a puzzle lies not in debunking his mystical claims, but in appreciating the human element. Here was a man who channeled a profound personal loss into a monumental act of creation. Each stone was a testament to perseverance, a physical poem of dedication built over 28 years. It serves as a powerful, modern reminder that the line between ancient wonder and human achievement is often drawn by scale and mystery, not by fundamental capability. Lidskalnin's castle proves that a determined individual, armed with patience, cleverness, and perhaps a touch of reinvented ancient wisdom, can still produce something that makes the modern world stop and wonder how. It stands as a bridge across time, connecting the solitary drive of one heartbroken man to the collective ambition of civilizations long past, asking us if the greatest secret of the ancients was not magic, but an unwavering, focused will applied to the stubborn patience of stone. The solitary will that built a coral castle finds its ancient echo in a civilization that engineered its power both in the open sky and deep within the earth. At Teotihuacan, the colossal pyramid of the sun dominates the horizon, a man-made mountain aligned with celestial precision. Yet, its true engineering marvel may be hidden in the opposite direction, deep below its immense stone feet. Archaeologists discovered a tunnel, a straight, narrow passageway burrowing over 300 feet from the pyramid's base toward its very center. At its end lies a chamber filled with ceremonial offerings, a sacred secret buried in the dark. The existence of this tunnel presents a profound structural puzzle. Digging any tunnel beneath a structure is risky, but digging one beneath a pyramid of that scale, composed of millions of tons of rubble and stone, is an act of breathtaking confidence. The constant, immense pressure from above threatens to crush any hollow space like an eggshell. So how did the Teotihuacano engineers ensure their sacred passageway would remain open and stable for centuries? The answer lies in a brilliant understanding of weight and counterweight, a technique modern engineers call cantilever vaulting. Instead of carving a simple, rounded arch, the builders shaped the tunnel's ceiling into a series of stepped, overlapping stone slabs. Each horizontal slab extends slightly beyond the one below it, gradually narrowing the gap until the ceiling is sealed. This design cleverly redirects the pyramid's downward force outward, channeling it into the solid earth on either side of the tunnel walls. The weight of the mountain above actually helps lock the ceiling stones in place, creating a stable, self-supporting structure. This solution reveals far more than clever stonework. It implies a deep, almost intuitive knowledge of subsurface geology. Before the first stone of the pyramid was laid, engineers must have carefully assessed the ground beneath it, understanding its composition and load-bearing capacity. They were not just building up, they were building down with a complete three-dimensional blueprint in mind. The tunnel was not an afterthought, It was a foundational element of the entire sacred complex. This hidden infrastructure transforms our view of the pyramid. It is not merely a monument to the sun, but a carefully engineered vessel designed to contain and protect a spiritual core. The builders mastered the visible and the invisible, the crushing weight of the heavens and the silent, stable darkness of the underworld. Their genius ensured that the path to the sacred chamber would remain open, a testament to a civilization that thought in layers, engineering both for the eyes of the gods and the secrets of the earth. This mastery of stone and fire reaches a strange and literal fusion in the misty highlands of Scotland. Scattered across the landscape are the remains of ancient hill forts, strongholds of the Iron Age, but some of these ruins hold a secret that glimmers in the light. Sections of their stone walls are not simply collapsed, they are transformed. The rocks have been melted and fused together into a dark, glassy substance, as if a dragon had breathed fire upon the ramparts. This process is called vitrification, and it requires a sustained, focused heat exceeding 1,100 degrees Celsius, a temperature that would turn stone into a sluggish, molten liquid. The existence of these vitrified forts presents a stark and smoldering question. Was this glassy armor applied on purpose, or is it the accidental scar of a terrible defeat? The idea of intentional vitrification is a fascinating puzzle in ancient military engineering. Imagine a defensive wall not just of stacked stone, but of stone that has been melted and refused into a single, monolithic barrier. Such a wall would be immensely stronger, more resistant to weathering and to the battering rams of an enemy. It would represent a terrifying escalation in fortress technology. But the practical challenges of achieving this are almost unimaginable. How do you generate that level of heat, not in a small, enclosed pottery kiln, but across the sprawling face of a massive wall, potentially hundreds of feet long? And more critically, how do you control it? Uncontrolled heat of that magnitude would not selectively strengthen the wall. It would likely cause the entire structure to slump and collapse into a pile of slag. If it was intentional, the builders would have needed a sophisticated understanding of insulation, perhaps constructing a temporary clay furnace around the wall sections to contain and direct the incredible heat, a project as monumental as building the fort itself. The alternative explanation is one of catastrophic violence. Perhaps these glassy sections are not the marks of construction, but of destruction. A successful siege that ended with the attackers setting a colossal, roaring fire against the wooden frameworks and defenses within the stone walls, a fire so hot and so prolonged that it literally melted the stone foundations. This theory turns the vitrified stone from an innovation into a monument to a community's final, desperate hours. It is a sobering thought that the most enduring remnant of these forts might be the physical evidence of their violent end. Yet, even this explanation has its complications. The vitrification is often found in specific, strategic sections of the walls, like gateways or vulnerable corners, not randomly across the entire site. This pattern suggests a targeted application of heat, whether for defense or destruction. The true mystery of the vitrified forts lies in this unresolved duality. They sit at a haunting intersection, a crossroads where the drive to build the ultimate stronghold meets the terrifying power required to utterly annihilate one. Each glassy, fused stone is a silent witness, but it refuses to testify whether it represents a peak of Iron Age engineering ingenuity or the scorched aftermath of a forgotten conflict that reshaped the very landscape. Without clearer evidence, these forts remain a powerful enigma, their walls a permanent question cast in stone and glass, forever balancing on the thin, hot line between creation and oblivion. The ghost in the gears of the Antikythera Mechanism may have had siblings. Across the scattered fragments of classical literature, we find whispers of other marvelous devices, described with a clarity that suggests they were real, not myth. Ancient authors like Cicero and Ovid wrote of intricate planetariums that mapped the wanderings of the stars, and of automated theaters where tiny, mechanical figures acted out entire plays powered by weights and gears. These are not vague legends, but specific accounts from observers who believed they were documenting the technological marvels of their age. This presents a haunting puzzle of absence. If such wonders were built, where is the physical evidence? The Antikythera device was only preserved by the unique conditions of a deep-sea shipwreck. How many other delicate assemblies of bronze and wood simply corroded into dust, were melted down for their metal, or were lost in the fires that consumed great libraries? The gap between these textual references and the silent archaeological record is a chasm filled with possibility. It forces a profound question: was the Antikythera mechanism a singular stroke of genius, or was it a surviving example of a wider, sophisticated tradition of mechanical engineering in the ancient Mediterranean world? The implications of a wider tradition are staggering. It suggests workshops where craftsmen passed down the art of precision gear cutting, where philosophers and engineers collaborated on models of the cosmos, and where the line between science, art, and spectacle was beautifully blurred. This was not child's play, it was a high form of intellectual and technical expression. The true weight of this puzzle, however, is felt not in its existence but in its disappearance. Following the decline of the Greco-Roman world, the knowledge required to build such devices seems to have evaporated from the Western world for over a millennium. The intricate understanding of gear ratios, the metallurgy for fine components, the very ambition to create complex automata all faded. This is not merely a pause, it is a technological regression, a valley in the landscape of human knowledge. We often picture progress as a straight, upward line, but history is filled with these unsettling dips. A concept as advanced as the analog computer was discovered. It flourished in the hands of a few brilliant minds, and then it vanished as if swallowed by time. Its rediscovery centuries later was not a continuation but a rebirth, a reinvention from scattered clues. This pattern challenges a comforting assumption about our journey. It shows that advanced engineering is not a permanent possession. It is a flame that must be carefully tended, passed from hand to hand, and protected against the winds of conflict, disaster, and forgetting. The lost tradition of Greek automata stands as a silent caution, a reminder that our grasp on complexity is more fragile than we think, and that the gears of progress can sometimes turn backwards, leaving only echoes in old books and a single, miraculous find from the deep. That concept of engineering for the collective rather than the individual finds its purest ancient expression in a city that seems to defy its own time. Mohenjo-Daro, a metropolis of the Indus Valley civilization flourishing over 4,500 years ago, presents an engineering puzzle of a different kind. Its mystery is not found in a towering pyramid or a colossal statue, but in its quiet, systematic order. The city was laid out on a precise grid plan, with wide, straight main streets intersecting smaller lanes, creating orderly city blocks. This was not haphazard growth, it was deliberate, master-planned urban design on a scale the ancient world had never seen. Beneath these orderly streets ran an even more astonishing feat, a city-wide network of baked brick drains and sewers, complete with manholes for maintenance, all designed to channel waste and rainwater away from residential areas. The bricks themselves were standardized, uniform in size and shape across the entire city, suggesting mass production and centralized quality control. This level of coordinated infrastructure speaks to a society with an advanced, almost modern, understanding of public health and civic management. Yet, this very sophistication creates the central, haunting puzzle of Mohenjo-Daro. Where is the palace? Where is the grand temple, the colossal statue of a king or god that typically drove such monumental civic projects in Egypt or Mesopotamia? Archaeologists have found a large bathhouse and what might be a granary, but no obvious, oversized seat of power. The engineering marvel here seems dedicated not to glorifying a ruler, but to serving the citizen. The focus was on equitable access to clean water, effective sanitation, and orderly living spaces for a population that may have numbered in the tens of thousands. This suggests a social model radically different from the divine monarchies of its contemporaries. Power in the Indus Valley may have been more distributed, perhaps held by a council of merchants or elders, with societal resources channeled into communal well-being rather than personal aggrandizement. The city's genius is in its anonymity, its lack of a singular, towering ego. It stands as proof that advanced engineering is not always synonymous with monumental tribute. It can be the quiet, profound work of creating a healthy, functional, and remarkably equitable human habitat. In its grid of streets and its network of drains, Mohenjo-Daro whispers a revolutionary idea from the depths of antiquity, that the highest purpose of technology and planning might be to improve the daily life of every person, a sensibility that feels startlingly and beautifully modern. Stonehenge stands alone on the Salisbury Plain, a circle of giants that has become the universal icon of ancient mystery. While its alignments with the solstice sun are celebrated, the true engineering puzzle lies not in where the stones point, but in the epic journey they made to get there. The smaller inner horseshoe, the blue stones, tell a story of obsession. Their geological fingerprint traces them to the Preseli Hills in Wales, a distance of over 150 miles. For a Neolithic community over 4,500 years ago, moving dozens of these multi-ton stones across such a vast and rugged landscape seems an act of pure devotion. Recent research paints a plausible yet still staggering picture of the how. The journey likely combined land and water. The stones may have been dragged on wooden sledges across land to a waterway, then loaded onto rafts or lashed between canoes to travel along the Welsh coast and up rivers before another long overland haul to the plain. Each stage was a monumental logistical feat, demanding not just raw manpower, but intricate knowledge of the terrain, seasons, and river currents. It was a pilgrimage in stone, where the value of the material was inextricably linked to its distant, sacred source. The second, equally profound puzzle awaited the stones at their destination. The outer circle and trilithons are built from massive sarsen stones, a local sandstone, but their local origin does not simplify the task. These are the true giants, some weighing over 25 tons. The mystery here shifts from transport to transformation and assembly. The builders did not simply stack rough boulders. They shaped these sarsens with extraordinary care, using stone mauls to pound them into smooth, slightly tapered pillars. Then they applied a technique we associate with fine carpentry. On top of each upright, they carved two protruding knobs or tenons. On the underside of each horizontal lintel stone, they carved corresponding hollows or mortises. This tongue and groove system allowed the lintels to lock securely onto the uprights, creating the iconic, stable arches we see today. To achieve this, they had to shape these joints with perfect precision, ensuring a snug fit that has held against millennia of wind and weather. This reveals a society that had mastered the properties of stone as if it were wood, transferring complex joinery techniques from one medium to another with flawless execution. Yet, for all we can theorize about the how, the enduring power of Stonehenge lies in the unanswerable why. This was not a settlement or a fortress. It was a stage, an astronomical instrument, and a cathedral all in one. The immense effort, the generations of labor, the perilous journey from Wales, all point to a purpose that was central to the very identity of the people who built it. It represents a convergence of astronomy, geology, and civil engineering into a single, profound statement. They read the sky, understood the earth, and then rearranged the landscape itself to mark the eternal cycles of the sun and moon, binding their community to the cosmos. Stonehenge, therefore, is more than a list of engineering challenges solved. It is the ultimate expression of a puzzle where the physical achievement is inseparable from the spiritual intent. It stands as a silent question in stone, reminding us that the greatest monuments are not just feats of engineering, but physical manifestations of a culture's deepest questions about time, place, and their own place in the universe. These scattered wonders, from the silent gears of Antikythera to the fused stones of Scottish forts, are not isolated curiosities. When we step back and view all 25 puzzles as a single gallery, a startling pattern emerges from the noise. It is a pattern written in stone, metal, and lost in tension. The first and most obvious thread is the mastery of megaliths. Across continents and millennia, from Baalbek to Easter Island, from Sacsayhuamán to Stonehenge, we see a recurring obsession with moving and shaping stone on a superhuman scale. This is not a coincidence of separate cultures, but a repeated demonstration of a fundamental human drive to impose lasting order on the most permanent material the earth provides. The methods may have differed, but the ambition was a universal language. Alongside this runs a parallel thread of impossible precision: the razor-thin joints of Inca walls, the flawless spheres of Costa Rica, the celestial alignments of Giza. This suggests that for these builders, scale alone was not enough. Grandeur had to be married to exactitude, as if the stability of their cosmos depended on the perfection of a right angle. A second, more haunting pattern involves not stone, but knowledge itself. We see repeated evidence of material science that seems to leap ahead of its time, only to vanish. The self-healing Roman concrete, the non-rusting iron of Delhi, the crucible steel of the Ulfberht swords, these are not puzzles of mass but of microstructure. They represent peaks of practical chemistry and metallurgy that were reached, then somehow forgotten, their formulas lost in the collapse of empires or the silence of guild secrets. Similarly, the mechanical genius of the ancient Greeks, hinted at by the Antikythera device and whispered in old texts, represents a peak of complex machinery that simply disappears from the record for over 1,000 years. This pattern of technological regression is perhaps the most profound lesson of all. It tells us that advanced engineering is not a one-way climb. It can be a fragile flame, easily extinguished by conflict, disaster, or simply the failure to pass a secret to the next generation. What these converging patterns ultimately reveal is a consistent and humbling disconnect. It is the gap between the modest toolkit archaeology often assigns to an era and the breathtaking artifact that era actually produced. This gap does not automatically demand explanations from beyond the stars or from sunken continents. More often, it points to three profound truths about our own story. First, it points to the sheer, staggering ingenuity of the human mind when faced with a monumental challenge. We have consistently underestimated the creative potential of our ancestors, their ability to solve problems with patience, observation, and clever applications of basic physics. Second, it acknowledges the reality of lost knowledge. History is not a careful archive, it is a battlefield of fire, flood, and decay. Libraries burn, craftsmen die without apprentices, and entire schools of thought can fade from memory. The absence of evidence for a technique is not always evidence of its absence. Third, and perhaps most importantly, these puzzles highlight the limitations of our own historical models. We have a deep-seated preference for neat, linear narratives of progress, a smooth upward curve from simple to complex, but the evidence on the ground is messy. It shows peaks and valleys, flashes of brilliance in unexpected places, and capabilities that do not fit our tidy timelines. These 25 ancient engineering puzzles, therefore, are more than a list of mysteries. They are a chorus of correctives. They remind us that history is not a simple story with a clear moral, but a complex, often contradictory tapestry. In this tapestry, Threads of advanced skill and profound understanding can appear in one age, only to disappear for centuries and then be rediscovered or reinvented in another. They challenge us to hold our theories more lightly, to look at the past not with condescension, but with a sense of wonder and humility. For every puzzle we solve, another seems to deepen, asking us to reconsider not just how these things were built, but what their builders truly knew and what we ourselves might have forgotten along the way. That recurring pattern of lost knowledge and rediscovered skill points toward a final, unifying truth. Our journey through these 25 ancient engineering puzzles reveals a world far more technically curious and capable than our history textbooks often suggest. We have not been looking at a collection of random anomalies or lucky accidents. Instead, we have been examining a consistent body of evidence, a global testament to human creativity, perseverance, and perhaps entire schools of knowledge that were mastered and then forgotten. These structures and devices challenge our modern understanding not to defeat us or to prove us wrong, but to inspire a deeper form of curiosity. They ask us to look at the past with more humility, to acknowledge that the story of human innovation is not a straight line, but a sprawling, branching tree with deep roots and many lost branches. Simultaneously, they ask us to look at our own potential with more wonder. If our ancestors, with the resources of their time, could conceive of and execute such marvels, what does that say about the latent capacity within us all? The greatest lesson these silent teachers offer may be this: the boundaries of the possible are not fixed. They are constantly being redrawn, not just by our technology, but by our imagination and our willingness to learn from those who came before. Each puzzle is an invitation to think differently, to question assumptions, and to remember that every modern marvel stands on the shoulders of ancient ingenuity. If you found this exploration into the edges of history fascinating, consider subscribing for more deep dives into the world's greatest unsolved mysteries. And we would love to hear from you. Which of these 25 ancient engineering puzzles do you find the most compelling, and why? Share your thoughts in the comments below.